So let's see how to solve higher order linear differential equations. Okay, so first of all, what is a linear DE, which we have this thing we have discussed previously during the classification of differential equation. So linear differential equation means the dependent variable and its derivatives are in first degree and not multiplied together. Okay, so this we have seen previously itself, just I'm revising it. Okay, about the definition of linear differential equation. So a general linear DE differential equation will look something like this. An is the nth coefficient, so ynx is the nth order derivative term, and then you have the n minus 1th derivative term, so on, plus you have the second order derivative term, the first order. So this is a standard form of the linear equation where the dependent variable y and its derivatives are not multiplied together, and every term is a term of degree 1. Okay, now when you say linear differential equation with constant coefficients, so with constant coefficient, why I am discussing constant coefficient, because in the syllabus you have linear higher order linear differential equation with constant coefficients. So constant coefficient means all your n which are supposed to be a function of x, all these terms are basically constants. I mean, they are all these are constants. Need not be same, but can be c1, c2, c3, all that. Okay, so this will make linear differential equation with constants. So before going to the process of solving higher order linear differential equation, let's see two important facts about, or important theorems you can say, but we'll not derive it. We'll just mention the facts. So important facts about linear differential equation. Okay, so fact number one: any linear combination, any linear combination of solution of a linear homogeneous. Well, here homogeneous means the right hand term f of x is 0. So linear homogeneous dA is also a solution. So what it means is any linear combination of solution of linear homogeneous is also a solution. Just to explain further, if y is equal to y1 of x and y is equal to y2 of x are two solutions of a linear homogeneous differential equation. So let me just write linear homogeneous differential equation. This is the general form. So y power n is basically the nth order derivative of y. Don't think it as y to the power of n. Just think it as the nth order derivative of y. Okay, and similarly you can write a2 y double dash plus a1 y dash plus a naught y is equal to 0. So this term makes it homogeneous. Okay, so you have a linear homogeneous equation, and suppose you know that y1x and y2x are the two solutions of this. Then what does this important fact says is that any linear combination of y1x and y2x, so any linear combination a y1x plus b y2x is also a solution of same linear, so it's also the solution of the linear differential equation where a and b are constants, okay. So that's what. So if you know two solutions y1x and y2x, you can say that any linear combinations of y1x and y2x is also a solution. This can be easily verified because when you substitute y1x into this equation, we'll get an equation. When you substitute y2x, we'll get another equation. Both of them satisfy this differential equation. Now if you just multiply constants, some constants to these two equations, add together, that thing also will satisfy this differential equation. I mean, this is just, if you can substitute, you can just substitute and verify. Nothing, I mean, the theorem, there is nothing to prove here much. Okay, but this fact is important because when we solve it, when we derive, when we try to solve the differential equation, then this facts will be using it. And the second fact is, if y is equal to y1x is solution of linear homogeneous DE, okay, and this linear homogeneous DE is given like this. And so what he says is, if y1 is equal to y1x is a solution of this, and y is equal to y2x is solution of the linear non-homogeneous equation. So basically the linear non-homogeneous equation will have the same part as of this, okay. So only the difference is in the right hand side. What he says is, if y1x is a solution of linear homogeneous differential equation and y2x is a solution of a similar uh, linear non-homogeneous differential equation, only the right hand term is difference, then y is equal to y1x plus y2x is also a solution of the same linear non-homogeneous differential equation. Okay, so what it means basically is that if you have a non-linear if you have a linear non-homogeneous differential equation and you know that y2x is the solution of that, then and also if you know that the the corresponding homogeneous part has a solution of y1x, then you can say that y1x plus y2x is also a solution of the same linear non-homogeneous differential equation. This fact is very important and we will be using it while while solving the differential equation. And just to mention that this y1x is basically called as the complementary function. It's called as a complementary function of, or a general solution, or the general solution of the corresponding homogeneous equation, that is this y1x. And a y2x is basically called as the particular solution of the non-homogeneous equation. So these are the terminologies: complementary function and particular solution, or the complementary solution and particular solution. We'll be mostly using when we solve this non-homogeneous differential equation. So these will be the terminologies, but so these two are the important facts we'll be mostly using while deriving the solutions for higher order linear differential equations. Just to begin and understanding how the solution looks like, so let's start with second order homogeneous equation. and then probably once we get to know how the second order the solution for second order homogeneous equation for the linear looks like, then we can extend it to higher order. So remember, in the syllabus, in the GATE syllabus, we have linear higher order linear differential equations with constant coefficients. Okay, so our focus will be on that and will be syllabus focused. Okay, so let's take an example of this constant coefficients second or higher, I mean the till the second order. So it looks something like this. This is a general form. A, B, C are all constants. Okay, so let's discuss this homogeneous equation. Now what is the solution for this? Well, no, just let us think like this. Now from the first order differential equation or something of this form, we know that if we just integrate this, say dy by dx is equal to ky, and then integrating this, I mean by variable separation method, you can just integrate in this, you get the solution y is equal to c e power kt, where c is some constant. So this is for a first order. Now let us try to find solution of this. Let me call this a star. To find solution of star which has having the form, because see these terms look like similar to this, right? So there is nothing wrong in trying this solution in that star, this solution in the star equation having form y is equal to e power rt. So constants let keep aside. So y is equal to e power rt. I want to try this as a solution of this. So what happens? So just if I substitute that, so it will be r square e power rt, because two times you have to differentiate, plus b r e power rt plus c e power rt is equal to 0. So now e power rt I can take out common, plus br plus c is equal to 0. Now from this I can say that since e power rt can never be 0, it can only be at the least it can only be 1. So y is equal to e power rt, I can say that will be a solution. So this will be a solution of the differential equation, be a solution of the differential equation. Okay, if and only if r satisfies the quadratic auxiliary equation. So this is called your quadratic auxiliary equation. Okay, so for now, so remember what we did, we substituted y is equal to e power rt and we got this equation. And for a differential equation to be satisfied, this equation has to be 0, and y e power rt cannot be 0 anytime. So your quadratic auxiliary equation a r square plus br plus c has to be 0 for the y is equal to e power rt to be the general solution. Okay, so now this has roots which is given by the quadratic formula, which I can always write in this way. Okay, which I can always write in this way. So there are two roots because it's a quadratic equation. So here in the quadratic equation formula, I call this b square minus 4ac as the discriminant.